This video is on section 4.1, which is understanding two variable relationships. So we're looking at problems that have two different variables. So if you can describe a relationship by an equation, you could also describe it by using a table. So we're going to practice using a table to help explain that relationship. So for example, Teresa has a dog walking service. She charges $6 for each dog. If X is the number of dogs and Y is the amount of dollars she earns, then Y equals 6X shows the relationship between X and Y. Let's assume that 5 is the most dogs she will walk. So we can set this up in a table by putting X in one column and then our equation in the next. Y equals 6X. Then we can calculate what Y would equal when we have a known value for X. So for example, when X is equal to 1, Y would be equal to 6 times 1, which would be 6. When X is equal to 2, Y is equal to 6 times 2, which is 12. And so on. So you go and you fill in the table, which helps explain the relationship between the two. So 5, 6, and 5 is 30. So that's the first type of problem you might have. You might be given an equation and you have to create a table that shows how the value, what for any given value of X, what the Y would be. Let's do another example that's similar. In this case, we have a Great Dane puppies weigh about 4 pounds at birth. Their weight increases about a pound a week for the first 5 weeks. So 1 pound per week. If A is the age in weeks and W is the weight in pounds, let's write an equation to create a table to show the puppy's weight up until 5 weeks old. So in this case, they didn't give us the equation, but they told us about it. So the first thing they told us is that it weighs 4 pounds at birth. Then they also told us it gains a pound a week for the first 5 weeks. So we can say the age of it in weeks, because it says we're going to represent that with A. If A is the age in weeks, then that's going to equal to the overall weight. So our equation is the weight equals the number of weeks. Really, it's the number of weeks times 1, but we don't need to write the 1, plus 4. So we could then create our table by putting our A here, so depending on how old it is, and then its weight here. So let's do this. It says up to 5 weeks, so 0, 1, 2, 3, 4, 5. At birth, the age is 0 and it weighs 4 pounds. After 1 week, it's going to weigh 1 plus 4, which is going to be 5 pounds. At 2 weeks, 2 plus 4, which is 6, and so on. You start to see the pattern. So here's another example. You won't always be given the equation. Okay. So I want you to try a problem now. So you may need to press pause and read through this, but I want you to bring this to class tomorrow. So you'll need to write an equation and then also create a table using these values for D. So press pause and try it now. Okay. Example 3, a table giving mixtures of potting soil and sand for the bottom of an iguana cage is shown. Find a rule that relates, it's really asking for an equation, that relates the amount of sand Y to the amount of potting soil X. Use it to find the amount of sand you would need for 15 cups of potting soil. Okay, so here I'm going to help myself out so I remember this is my sand and then X is my potting soil. And I'm going to look for a pattern. So at 1 I have 3.5. 2 I have 7, so maybe it doubles. Oh, but wait, at 3 it hasn't quite doubled. It's increasing by increments of 3.5 each time. And that seems pretty consistent. Yep. So now I can write an equation. My equation is going to be y, so the amount of sand, is equal to 3.5 times the amount of potting soil. So I was able to use this table of data to get an equation. Now the second part of this is asking me find the amount of sand, which is my y, if we had 15 cups of potting soil, which is the x. So now I can plug in y equals 3.5 times 15 to solve, and you get about 53 cups of sand. Now, because it's a word problem, you want to make sure that you actually label what it is you found. All right, and the last one is a try it, so I want you to try this at home. Find the rule that relates x and y in this table. Then find y when x equals 50. So just like the previous problem, you have to find the rule that relates these two together, the x and the y, and then solve for when x, all the way up here, you're not going to make a table all the way up to 50. So what would it be when it equals 50? That's all for today's lesson. See you tomorrow.